Hello everyone. In the previous lesson, we've learned about atmospheric pressure. We learned what is an atmospheric pressure. We've learned about the different instruments to measure atmospheric pressure like the mercury barometer and the aneroid barometer. The goal for today's class is to understand what is humidity. So let us begin. Now, what is humidity? Please underline the amount of water vapor present in the atmosphere is known as humidity. So, the amount of water vapor or the moisture that is present in the air, that is known as humidity. Now, the amount of water vapor that the air can hold varies with temperature, meaning the warmer the air, the more water vapor it can hold. So, always remember warm air can hold more water vapor than the cold air. So, but when the warm air becomes cold, what happens? It reaches a point where it can no longer hold all the water vapor. Then we call that the air has become saturated. So as the warm air becomes cold, it reaches a point where it feels that it can no longer hold all the water vapor. Then we say that the air has become saturated. So what is saturation? Please underline. Saturation can be defined as the condition where a mass of air can no longer hold the moisture at a given temperature. So saturation meaning a point where the air can no longer hold the moisture because it has cooled down. So remember that warm air can hold moisture. When the warm air becomes cold, when the warm air cools down, it reaches a point that is known as saturation where it can no longer hold the moisture. Then the next thing that you must know is the temperature at which saturation takes place is known as dew point. So that temperature when the air cools down and can no longer hold the moisture, that temperature is known as your dew point, meaning a really low temperature. Alright, now how do we express humidity? So please underline, this is important. The most common way of expressing moisture in the atmosphere is through relative humidity. So relative humidity is one of the common way of expressing moisture or water vapor in the air. Very often you see this in the newspaper, in the weather forecast section where there's maximum temperature, minimum temperature given, isn't it? At the same place you would see something as RH or relative humidity mentioned. So that is why relative humidity is a common way to express humidity in the air. Now what is relative humidity? Please underline. Relative humidity is the ratio between the amount of water vapor present in a given volume of air at that temperature to the maximum amount of water vapor that the same volume of air can actually hold at that temperature. Alright, and it is always expressed in percentage. Relative humidity is always expressed in percentage. So what have you underlined here? Relative humidity means the actual amount of water vapor that is present in the air. Let's say now in the air 20% water, let's say 15% of water vapor is present in the air today, into 100 because it's in percentage, divided by the actual amount of water vapor that the air can actually hold. Let's say 30% of water vapor that the air can actually hold, but only 15 is present today, into 100. So this is how we get relative humidity. The amount of water vapor present in the air now into 100 divided by how much of water vapor that the air can actually hold, and it is always expressed in percentage. So that is how you define relative humidity. You must learn the definition along with the unit, that is percentage. Alright, now the second type of humidity, which is not very common and popular, is your absolute humidity. So let's underline the definition is the amount of water vapor present in a unit volume of air. It is expressed in grams per cubic meter. So what is absolute humidity? Absolute humidity is the actual amount of water vapor present in the air. It does not take into consideration temperature. That is why it is not the common or popular way of expressing moisture. Whereas relative takes into consideration temperature of the air. Whereas absolute, it does not take into consideration temperature. That is why it is not a very common way of expressing humidity. Alright? Moving to the next, now how do you feel when the weather is humid? When the weather is humid, we sweat a lot and we feel very uncomfortable, isn't it? We say it's so humid when we feel very sticky and we feel warm, hot. So that is how you feel very uncomfortable. So that is what is called humid weather because of more moisture in the air. Coming to the last portion, the instrument. Which is the instrument to measure humidity? The instrument to measure humidity is called hygrometer or the wet and dry bulb thermometer. It measures relative humidity. So the instrument to measure relative humidity is your wet and dry bulb thermometer, which is also known as the hygrometer. So this is a picture of a wet and dry bulb thermometer and hygrometer. Now let's try to understand how does each work. Please underline the dry bulb thermometer is like a normal thermometer which just measures the air temperature at that time. So dry bulb here is like a regular thermometer that just helps us to give the temperature of air at that time. Whereas wet bulb, from the word it's a wet because it is wrapped in a wet cloth, muslin cloth. It's a cotton cloth, like a quilt cover, isn't it? The earlier times we used to use a plain white color, so that's a muslin cloth. So this wet and dry bulb thermometer, the bulb of this thermometer is always covered with a muslin cloth. All right. One end of the muslin cloth is constantly dipped in a container of water. So that is why we call it a wet bulb thermometer, because the bulb of this thermometer is always wrapped, covered with a cloth, which is a cotton fabric, and always dipped in water. Now you might be curious to understand why is it covered with cloth and why is it dipped in water, whereas this dry bulb is left open. Now the reason why we cover this cloth is to hold moisture. Why? What do you mean by hold moisture? Imagine there's a warm air blowing. Okay, this is a warm air. So when warm air comes in contact with this wet cloth, what happens to this cloth? The cloth starts heating up and you see a vapor rising up. That's called evaporation takes place. So when evaporation takes place from the cloth, what happens to the bulb? The bulb temperature in the bulb starts decreasing, coming to its normal. So thereby giving us the actual temperature. Alright, so that is why we wrapped it with muslin cloth so that it can hold moisture and increase the coolness of the bulb, thereby dropping the temperature. Now, in order to find relative humidity, the difference in the reading of both the thermometers is important. So that is why we cannot just measure relative humidity with the help of dry bulb, nor we can just do with the help of wet. Both are equally important. With the help of both the readings of the thermometer, then only we can find the relative humidity. So let's try to understand how we find relative humidity with the help of both. First is the greater the difference between the two readings. Let's say dry bulb has given us reading such as 100%. We've received relative humidity, dry bulb is 100. Whereas let's say wet bulb is 50%. So what is the difference? 100 minus 50 is 50. So 50 is a great difference. So greater the difference, what happens? Relative humidity is low and the air is dry. So greater the difference between the two, which means relative humidity is low, which means air is dry. The smaller the difference between the two, let's say smaller, let's say dry bulb has given us relative humidity of 80%, whereas from wet bulb we've received relative humidity 60. So what is the difference? 80 minus 60 will give us 20, which is a very small difference. So smaller the difference, meaning higher the relative humidity. So it's just the opposite. Greater the difference, low relative humidity. Smaller the difference, higher is the relative humidity. But if there is no difference, let's say the difference is very less or no at all, which means relative humidity 100%, which means the air is fully saturated and it can rain anytime. Let's say this is also giving us relative humidity of 200%, whereas this has also given us relative humidity of 200%, which means 200 minus 200 is 0. So complete, there's no difference at all. So in that case, it means that relative humidity, moisture is 100%, and now the air can no longer hold the moisture. It is saturated and it can drop the moisture and it can rain anytime. So that is how you measure relative humidity. So that is about humidity. We've learned what is humidity. It's the amount of water vapor present in the air. We learned that warm air can hold more water vapor than cold air. When the air cannot hold water vapor, we say that the air is saturated. The temperature at which saturation takes place is called dew point. Relative humidity is the most common way of expressing moisture in the air. There's something called absolute humidity also. And then we've learned about the instrument, which is hygrometer and wet and dry bulb thermometer. Thank you, everyone.